Let us learn in more detail the different ways of setting up floors, roofs and stairs. Here we can see that the porch floor and plinth floor has been set up. Now we can add the roof to the ground floor area. Thinking about floors and roofs, what is actually roof of the ground floor also serves as the floor of the first floor. We are going to use the copy tool to create the roof as the shape of both ground floor floor slab and ground floor roof is the same. In Revit, the copy and paste buttons are found in the Modify tab. We can select an element and then click the copy button to copy that element. Then if we click on the paste button, there are few options. The paste from clipboard option pastes a copy of that element in the same place. The align to selected level option pastes the element into the level we select from the list of levels, which opens as a pop-up. Here I am using this option to paste the floor slab into the ground floor roof level. We can see in the 3D view that the floor slab has been pasted in the ground floor roof level. When we look at it closely, we can see that the walls are cutting through the slab and the wall lines are visible. In real life, walls touch the floor slab. We can change this using the edit options of the wall. Let us go into an elevation view. First, let us select all the walls. We can see that when we use the cursor to select the whole region, all elements in that region get selected. We can use the filter option to deselect the elements other than walls. Once only walls are selected, we can see that the contextual tab shows two options. The attach top or base option attaches the top or base of walls to floors. The detach top or base option detaches already attached walls. We can use the attach option to attach the top of the selected walls to the bottom of the roof slab. After selecting the walls, click on the attach top or base button and then click on the roof to which the walls are to be attached. This attaches the walls to the roof. Another advantage of attaching walls to the bottom of roof is that when we move the floor or roof, the walls automatically remain joined to the roof. Now going back to the 3D view, we can see that the walls have been attached to the base of the roof. Now let's add the roof of the porch and the sunshades. Since the porch floor and the windows are visible in the plinth floor plan view, I am going to trace the outline of the floor in plinth view. I'm using the line tool with an offset of 0.6 meters to draw the sunshades. I am also tracing the outline of the car porch. In this way, I am completing the geometry of the sunshades. Now that the slab is created, we can move it to the ground floor lintel level. Select the slab and then in the properties bar change the level to ground floor lintel level. Now we can go to an elevation view and check the placement of the slab. Here we can see that the sunshade slab has placed such that the top of the slab is at ground floor lintel level. So we can use the height offset option to move the slab up by 15 centimeters, which is the thickness of the slab. Here we can see that even though the shutters of the windows are at lintel level, they have an outer frame which goes above that level. So we can move the sunshade slab another 15 centimeters to accommodate this difference. We can also see that a window is not in the correct position. This is where the type properties and instance properties can be used. By selecting the window, we can see that the properties bar changes to show the sill height and other properties. We can change the sill height to 60 centimeters to reflect that of the other windows. In this way, any past errors can also be corrected in few steps instead of starting over again and again. After making the changes, we can go to the 3D view and check on all sides to see if all elements are correct and in desired position. Since all elements are placed correctly, we can go back to the plinth view. Next, we can learn about stairs. First, we can add the steps from the car porch to plinth. Click on the stair button in the Architecture tab of the ribbon. Immediately, the Contextual tab changes to show tools to place and edit the stairs. We are going to use the default option as this is a straight stair. First step is to specify the base and top levels. For the base level, we can give the ground level. As the car porch is 15 centimeters higher than the ground level, and since the steps should start at this height, we are giving a base offset of 15 centimeters. The top level is changed to plinth level. Now if we click on the starting point of the stairs and move the cursor, we can see that Revit has automatically calculated the dimensions and number of steps. Clicking the cursor on the direction of the steps places the stairs. We can select the stairs and use the Move tool to change the position of the stairs. We can also use the two arrows which show up when the stair is selected to change the width of the stairs. Once the changes are made, we can click the Finish button. The floor slab which we created earlier cuts through the stairs. So we can edit the floor slab boundary to accommodate the stairs. By selecting the floor slab and then using the Edit Boundary option, the outline of the floor slab can be modified using the Modify tools. Once the changes are made, we can click the Finish button. Whenever we create or edit stairs and changes are saved, a pop-up dialog shows up with option whether to attach walls below the floor to the bottom of the floor slab. We can choose yes or no depending on our requirement. Now if we go to the 3D view, we can see that the floor slab is correct but the wall between ground and plinth cuts through the stairs. We can change this by going into the ground level and editing the wall. We can select the wall and then use the Cut tool to cut the wall at the two sides of the stair. We can delete the cut portion and then adjust the walls to align with the stairs. We can check the changes in the 3D view. When we look at the stairs and the nearby walls and floor, we can see that the alignment of the stairs are in not exact position. Also, the stair type does not complement the sit-out area. So I am changing the stair type to monolithic stairs by using the drop-down in the Properties bar. We can also see that Revit automatically adds railings to any stairs we create. Since we do not require railings in this area, I am selecting the railings and deleting them. Now we can again go into ground view and move the points of the walls so that they align with the stairs. We can go back to 3D view and see that the stairs are in perfect alignment. In the 3D view, we can see that the walls between ground and plinth cut through the plinth floor. Let us modify it. When there is a set of connected walls, we can place the cursor on one of the walls and then click the Tab button on the keyboard until all needed walls are highlighted. Then click the left mouse button to select the group of walls together. Now we can use the Attach to Top or Base option and make the walls get connected to the floor properly. We can change the visual style of the view to shaded and check the alignment and materials. By rotating the model, we can see that the sunshade slab cuts through the entire building. We can change this. First, we can go into ground floor lintel view. Then by selecting the slab and then clicking on the Edit Boundary button, the geometry can be edited. Whenever a closed shape is drawn inside an already existing geometry, that area gets subtracted from the element. Since sunshade is needed only in the outer part of the building, we can draw a rectangle with the building as boundary and finish the edit mode. This method of adding or subtracting geometries can also be called a Boolean operation. Now we can see in the 3D view that the interior region of the floor slab has been removed. If we look at the front of the building in 3D view, we can see that there is a hollow between the sunshade and roof slab. We can draw a wall in that region. First go to ground floor lintel view. Then select the wall tool. Fix the base and top levels as ground floor lintel and ground floor roof respectively. Then by using the location line as finish face interior, we can draw the wall by using the roof slab boundary line as reference. In the 3D view we can see that the hollow has been filled by the wall but that it intersects with the roof slab. That can be changed by selecting the wall and then using the attach top or base option and then clicking on the roof slab. Now rotating the view such that the bottom of the wall is visible, we can see that it is not aligned to the sunshade slab. So we can select the wall and then input a base offset of 0.3 meters such that it aligns with the bottom of the sunshade. Again we can rotate the 3D view to check for any errors. Once we are completely satisfied with the walls, doors, windows, floors, sunshades and roof of the ground floor, we can create the first floor. In the sample plan we are using as reference, we can see that the ground floor plan and first floor plan are nearly similar. In Revit we can easily add elements from one level to another by copying the desired elements and then pasting them to the selected levels. So here we can copy and place all the elements we need in the first floor. First we can select the region which has all the elements we need. We can use the filter tool to remove the elements we do not want to copy. Then click on the copy button in the Modify tab to copy the elements. Next we can click on the Paste button and select the Paste Align to Selected Level option. We have selected elements which start at the plinth level and we want the same to be placed aligned to the ground floor roof. So we are selecting ground floor roof as the level in the pop-up that opens. Now we can see that all the elements which we had copied has been pasted. We can use the 3D view to see the changes. In this way, when we have completed the ground floor, we can create the first floor within few minutes. Now that we have seen the method of creating flat floor and roof slabs, we can try creating a sloped roof. I want to create a sloped roof for the first floor. Since the sloped roof itself is going to act as the sunshade, I am going to delete the sunshade slab which was already created. Since the slope of the roof should start at the first floor lintel level, I am going to open this level. Now let us create the sloped roof. Sloped roofs can be created using the Roof button in the Architecture tab. Although there are different options in the drop-down for creating roof, for the purpose of our project we need only the Roof by Footprint option. Clicking on the Roof button opens the Contextual tab and shows options needed to create the roof. Using the Line tool we can trace the outline of the roof. Near each line is a small right-angle triangle which represents the slope of that line. We can also select the type of roof from the drop-down in the Properties bar. I have selected the generic 125 mm type. Now if we finish the roof option, a pop-up appears asking if the highlighted walls should be attached to the roof. I am choosing yes, so that even though we make further changes, the walls will remain attached, reducing additional steps. Now we can see that the roof has been created. Now let us see the further modifications that can be done. Selecting the roof and then clicking the Edit Boundary buttons opens the Contextual tab with modifying options. I want the roof such that it is sloping on only two sides. So we can select the lines on the sides on which we do not want slope. After selecting the lines, uncheck the Define Slope box in the Options bar. Now if we finish and exit, we can see that the roof slopes only on two sides. Here the slope of the roof is steep. We can change the slope of the roof slab using the Instance Properties in the Properties bar. When we select the roof, the properties of the selected roof is displayed in the Properties bar. Under dimensions we can see that the slope angle is set to 30 degrees. I'm changing it to 15 degrees. Now we can see that the slope has changed. When we rotate the model in 3D view, we can see that the roof does not pass through the windows and slopes above the lintel level perfectly. We can also see that the walls are attached to the roof and remain fixed to the roof even when the shape of the roof changes. In this way, roof can be created and modified in Revit. Now we can place the columns of the car porch. The column button is found in the Architecture tab. Since we are working on an architectural project, we are choosing the architectural option in the drop-down. In the Properties bar drop-down, we can select the square column of size 475 by 475 mm. Columns are placed based on their center line. We can place the columns on the reference of the grid and then move them to desired position. We can also change the base and top constraints such that the columns start at the ground level and end at ground floor roof level. We can check the changes in the 3D view. I want to edit the columns such that they end at the base of the car porch roof. So I'm selecting the columns and then using the attach to top or base option to make it fixed to the car porch roof. Now looking at the house elevation, I'm changing the height of the porch and sunshade slab such that it is aligned to the ground floor roof level. We can see here that the height of the columns also change as they are attached to the car porch roof. In this way, floors, roofs and exterior elements such as columns and stairs can be created and modified in Revit. Now we can go to the ground floor roof plan view to modify the rooms as per the sample plan. By looking at the sample plan, we can see that there are few changes in the first floor plan. We can go to the ground floor roof plan view to make the changes. We can see that some walls which are present in the ground floor are not needed in the first floor. Also, two of the bathroom walls extend to become exterior walls in the first floor. So we can use the Modify tab to edit the walls. We can use the Extend tool to connect the walls. Fillet tool can be used to join the corners of two walls. We can also delete the walls which are not needed. Automatically the doors, windows or openings in those walls become unconnected and a warning window pops up asking if to delete those elements. We can select the Delete Instances option as we do not require these elements. We can also use the Split Element tool to divide walls into two and then use Fillet tool and Extend tool to join the corners. Similar to the ground floor, we can see here too that the ventilators are not displayed in the floor plan view. So we can use the Properties bar to edit the view range to 1.5 meters. Now we can see that the ventilators are visible. In this way, the Modify tools can be used to create, edit and modify the first floor when we have copied and pasted elements from the ground floor. These modifications can be done in any order and can be made at any point of time while working with the Revit model. We can also change the visual styles and detail levels to check if all the elements are correctly placed. After we have checked and made the necessary changes, we can go back to the original visual style of the floor plan. A new door and two windows are required in the edited wall. So we can add these elements by using the Create Similar option and then place in their new position. We can click the spacebar key after selecting the element to modify the orientation of placement. In this way, the walls, doors and windows of the first floor can be created and modified based on the sample plan.